Alright, hey guys, so today we're going to be going over how do I graph a function. So by now we know what a function is. It transforms some input into an output. And at the moment it's kind of just like a set of numbers that we don't really know what it does and stuff like that, but we can transform it into sort of a tangible visual object that we can see what it does. So for example, if we take the function f of x is equal to x squared. So we already know that we can graph this or just plot this basic table to tell us what values there are. So when x is 1, f of x is 1, x is 2, f of x is 4, negative 1, 1, negative 2, 4, 0, 0. So we already know we can do that. But now we want to put it into a graph and see what the function actually looks like. So how do we do that? Well, we know what the x and y axis looks like. But instead, if we set it with the x and f of x axes, we can see the function quite clearly. So we have the x horizontally and f of x vertically. So then what we do is we put the values that we want to see. So these just go on all the way, like they just keep going. But here if we just put in ones that we want to, like the area that we want to look at of the graph, just to give us like a general overview of what the graph looks like. So that's just a basic graph. You've probably seen that before with y and x axes. This is just f of x and x instead. So now we look at this table that we've plotted. We see that when x is equal to 1, f of x is also equal to 1. So that means we can go along the x-axis and look for the value where it's 1. So that's this point here. And then we know that f of x is 1 at that point, so we just go up to here. So it's x is equal to 1, f of x is equal to 1, and we just mark that point there. We can do the same thing at x equals 2, f of x is 4. So we can see f of x is 4 here, x is 2 here. So that means we plot a point here. We can look here, negative 1 on the x-axis corresponds to 1 on the f of x-axis. So we mark a point there. And negative 2 corresponds to 4 on the f of x-axis. So we just mark a point there. We've also got 0 is equal to 0. So when x is 0, f of x is 0. So these values are all what the function does. So when x is 1, x squared is 1. We already know that. So this is what, like, the points that we've found. And we know that if we take lots of different points in between here, so x is negative 1.99, etc., we'll still get an f of x value, and it will follow this general trend. So we can draw a line between these points, or a curve rather, to kind of generalize what the function looks like over these points. So if we just sketch a nice little curve between them, and this is the graph of f of x is equal to x squared. So the graph continues on up and everything, but we only wanted to look at these bits from x is equal to 2, negative 2 to x is equal to 2. So that's how you plot a graph. I'll give you another example now just so you can get the hang of it. So if we use f of x is equal to x cubed. So we'll apply our basic table again. I'll go through this fairly quickly because you know how to do that already. So x is 0, f of x is 0, 1, 1, 3, 27, negative 1, negative 1, negative 3, negative 27. Right, so the negative's in here because when you cube a negative, it stays negative because it's negative 1 times negative 1 times negative 1. So negative times negative cancels to make positive, then positive times negative is negative. So now we've got that, we need to draw f of x and x-axis. But what we can see here is these f of x values get quite high, and the x is still only at 3. So for this, we'll just change the scale of the axes. So the f of x axis we'll make that quite a higher scale because we need to fit it all in, just up to x is 3. So we'll put 30 in there, 20, 10, and that's 0, negative 10, negative 20, negative 30. And we'll still just do our x the same way because otherwise it would be all crammed up in here. So 1, 2, 3, negative 1, negative 2, negative 3. Right, so now we've got our x and f of x axes, and we want to plot these points onto the graph. So when x is 0, f of x is 0, so we mark that point there. When x is 1, f of x is also 1. So it's just above, not really too high because this scale is 10, so it's about 1/10 of the way to there. We can go to the negative 1, and that's also f of x is equal to negative 1, so it's that point there, because when x is negative 1, f of x is negative 1, so it's around there. So now we go to x is equal to 3, and when x is equal to 3, f of x equals 27. So it's all the way up here, just about there, so we mark that point. So when x is 3, f of x is 27. When x is negative 3, f of x is negative 27, so that's around there. And now you can't really see a way to draw quite a clear line between these points, so we might need another value to see what it looks like. So we can add some more. We'll just do when x is 2, f of x, that's 2 cubed, is 8. And when x is negative 2, it'll be negative 8. So that helps us to visualize more what the curves are going to look like, because at this point we see a line here and then point up here. So are we just going to go like that, or how is the curve going to get from here to here? So when x is 2, f of x is 8, so that's about there. And negative 2 is negative 8, so around there. So now this gives us a better overview of how the function is going to get from here to that point. So we can see that it curves down here slightly and then comes through here. So we can just sketch the graph on, down through these points, and up through. And obviously that's going to continue up, going to continue down, but we just care about from x is negative 3 to x is positive 3. So hopefully this gives you a good overview of how to graph a function, and it gives you a good visual object of what the function actually looks like. You can also use this to find other values. So for example, if we want to know what x is when f of x is negative 20, we can look over here at this point here to give us a rough indication. So then we can see that it's somewhere between negative 2 and negative 3. So thank you guys, hopefully you enjoyed the video and it all made sense.